Today we're going to begin our discussion of density. You may recognize the material I have in the background. That's actually granite. That's a very dense material. Well, first, what is the formula for density? I think most people know density, which we represent with the letter D, is equal to mass, which we usually measure in grams, divided by volume, which we can measure in milliliters, or you'll see in the video we also use centimeters cubed. What is something that's dense versus something that's not dense? Well, let's look at, we have one material on the left, which we would consider dense, one material on the right, which we would consider not as dense. So in general, things that have a high density are very tightly packed, and things that have a low density are not very tightly packed. In high density materials, the particles are packed, or the particles themselves are more massive. If things have a low density, the particles are loosely packed, or the particles themselves are more massive. High-density particles or substances would sink more easily. Low-density particles would float more easily. So let's look at what we talk about when we mention floating. Density. Well, one thing we use as a standard here is water. Now, the reason this is green is I simply use food coloring. Water has a density of 1.00 grams per milliliter or centimeter cubed. And often we'll use 1.00 grams per milliliter because water is actually a liquid. Now we see everything below that, cherry tomato, dish soap, milk, maple syrup, dye, all these things would actually sink in water. The things that are above that are actually less dense or have a density less than 1. For example, oil. We know oils float in water. Or alcohol. Or the ping pong ball. All those things are less dense. So what we're going to do is do 3 different density problems. The first one is actually one for granite. If you have a 10.00 gram part or piece of rock granite and it has a volume of 3.088 or 3.88 centimeters cubed, what is the density of the granite? So we use the formula density equals mass divided by volume. So first we insert the mass. The mass of the rock is the 10.01 grams. The volume of the rock is 3.88 centimeters cubed. We divide those out and you get a number like this, 2.579896. Now you want to get full credit for this, so in chemistry what you want to always do is provide an answer with 2 things. The units, the correct units, and the correct number of significant figures. So let's look at the significant figures first. We see the number on the top has 4 significant figures. The number on the bottom has 3 significant figures. So we want to round this to 3 significant figures. We see that 9 would round the 7 up to an 8. And the units for this would simply be grams per centimeter cubed. So the final answer for this would be 2.58 grams per centimeter cubed. The difference between grams per centimeter cubed or gram per milliliter we'll talk about in a second, but usually things that are solid we'd use a centimeter cubed for. We've got 2 more sample problems. Let's go. The second sample problem. I wonder if you could guess what substance this is. This is actually a substance that's on the periodic table. This is lead. Now I actually got this photograph off the internet. Lead shot is used for a lot of things. For example, for radioactive substances, lead shot is used to absorb radioactivity. The density of lead, pronounced LED, is 11.342 grams per centimeter cubed. If a block of lead has a volume of 27.2 centimeters cubed, what is the mass of the lead? So one thing you want to do here is rearrange the density equals mass divided by volume to find mass. When you do that, you find mass is equal to volume times density. Now one thing you want to notice, and I didn't point this out in the last problem, is a lot of these are simply going to be factor label problems. If you're finding density, nothing factors out. But in this problem, something will. Let's look. So first we take the volume. The volume is a 27.2 centimeter cubed. Then we multiply that by the density. Now notice when you do this, the volume cancels out. And notice also that this is simply a factor label that can be put either way. We can put the mass on the top, the volume on the bottom, depending on how we want to use this. So for this, we want to multiply the 27.2 times 11.342 grams, and we get this number. Once again, we want to provide an answer with the correct units and the correct number of significant figures. We see we have 3 significant figures here and 5 significant figures in the mass. So that means we want to express this answer with 3 significant figures. So the 5 rounds the 8 up to 9, And then our units are simply going to be grams because the centimeters cubed cancels out. And also, this is a good example of how I want you to show your work in this class. I want the formula, if the formula is used. I want the setup with units and show how things cancel. And finally, I want the answer with the correct units and the correct number of significant figures. So your final answer written correctly would be 309 grams. One more problem. I wonder if you could think about why I would have corn up when we just talked about density. Well, we mentioned a product that we get from corn. That's ethanol. We get a lot of ethanol from corn. So this is a problem about ethanol. Before we do that, let's look at the difference between volume and we talk about milliliters versus centimeters cubed. When we do that, we're going to actually be using the formula volume equals length times width times height. So if we take a centimeter times a centimeter times a centimeter, that gives us a centimeter cubed. And a centimeter cubed is exactly the same as a milliliter. One thing you might not know, though, is a liter is equal to a decimeter cubed. Decimeter cube is about this size. So if you take a decimeter times a decimeter times a decimeter, you've got a cubic decimeter. And this right here, this would be a decimeter, but this is actually 1 liter. So this would actually be 1 liter right here in this block. So let's do a problem here. Let's say we have ethanol, a type of alcohol that has a density of 0.789 grams per milliliter. Now notice here we're using milliliters instead of centimeters because this is a liquid. A sample with ethanol has a mass of 281 grams. What would its volume be? So the first thing you want to do is rearrange that density formula. When you do that, you see volume is equal to mass divided by density. Hopefully you remember when you're dividing by something, you're actually multiplying by the inverse. So to make this a nice factor label problem, all we're going to do is invert the density. So first we're going to take the mass, which is the 281 grams, and then we're going to divide by the density. That means this 0.789 grams is going to be at the bottom, and we'll just have 1 milliliter at the top. So it ends up looking like this. 281 grams, and we've inverted the density, and this allows our grams to cancel out, and then our answer will simply be in milliliters. The number we get on a calculator is 356.147. Once again, we see that we want to both of these have 3 significant figures, and the 1 does not round up to 6, and so our final answer would be simply 356 milliliters. And that's 3 density problems. We'll have some that are a little bit more complicated where we insert a solid, we see what the volume, how the volume rises. But this is a nice introduction to density. Let me know if you have any questions. Thank you.